Okay, guys, we're going to look at your assignment for today. The first question is asking you to graph y equals negative 3x plus 1. It's asking for the slope, the y-intercept. I want you to make an input-output table for x and y with sets of points that correspond to ordered pairs on the graph, and then sketch the graph. So to do that, we look at this, we can see that we have a linear function. In the form y equals mx plus b, where m is the slope. So the slope is negative 3. B is the y-intercept. Why is my highlighter being funky? So our y-intercept is at positive 1. To make your input-output table, it's a x and y. X is the input. So when you input a 0 for the x, y equals negative 3 times 0 plus 1. We know that 3 times 0 is 0 plus 1 is 1. So our first entry on our input-output table is at 1. And then since our slope is 3, negative 3, that means that every time our x goes up by 1, our y is going to go down 3. So we can try 1, 2, 2 ahead on the graph here. We have where our y-intercept at 1. Y-intercept is at 1. And then we can see when our x goes up by 1, so I'm plugging in this x as a 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So as our x goes up by 1 here, our y goes down 3. 1, 2, 3. Your next point would be here. And then when we change our x to a 2, negative 3 times 2 is negative 6. Check on the calculator. Negative 6 plus 1 is negative 5. So when our x goes up to 2, our y is at negative 5. Negative 1, 2, 3, 4, 5. So every time that our x goes up by 1, our y is going down by 3. And then the same thing happens when we work backwards. When x is negative 1, our y, since we're working backwards, instead of going down 3, it's going to go up 3. And let's prove it. Negative 1 times negative 3 is going to be positive 3. Positive 3 plus 1 is 4. And we go up. 1, 2, 3, 4. And now that we can see the pattern, we know that the next one, when x is negative 2, it's going to go up 3 more. It's going to be at 7. I know that without using the table because that's what's going to give me a straight graph. And that's 1, 2, 3, 4, 5 points. Connect your dots. This is really hard for me to do, to make a straight line using my mouse like this. So I expect your line to be a little straighter than mine. Sorry, that's kind of shaky. But that's how it goes. And this is how you use your formula, your equation, to make your input-output table. So you can do the same thing for question numbers 2 and 3. And then I'm going to skip ahead to question number 2 and 3. It's similar, but it's not exactly the same. Your equation doesn't right away look like a linear function in slope-intercept form. You have a standard form, and this looks like point-slope form. So you might want to turn your standard form into slope-intercept form by rewriting it. So 3x minus y equals 2. We want to rewrite it. I want to get my x to the other side, so I'm going to subtract 3x on both sides of the equation. That gives me negative y equals negative 3x plus 2. But I don't want to know what's negative y. I want to know what's positive y. To figure that out, I'm going to multiply everything by negative 1. Everything on this side, everything on this side, I'm multiplying by negative 1. That's going to give me y equals a negative times a negative turns positive 3x. Plus 2 times negative 1 is going to become minus 2. Now, the same way how we answered the questions for number 1, you can answer for number 2 because it's in slope-intercept form. And then on number 3, you got y minus 7 equals negative 2/3 x. We want to get the y by itself. Just going to real quick add 7 to both sides. That's going to give us y equals negative 2/3 x plus 7. Now the same way how you answered questions on number 1, you can answer the questions on number 3. Number 4 is a little bit different. Now you got an absolute value function. And I still want an input-output table. I want to know the vertex. To me, the most important thing is the vertex. So when we look here, we got our form, our vertex form, absolute value function. We got HK is the vertex. This is absolute value x minus h plus k, very similar to vertex form of a quadratic function. So even though this says minus 2, because it's a minus on the formula, it's going to be positive 2 for my x coordinate of my vertex. And because it's plus k on the formula, it's going to be a negative 4 for the y value of the vertex. That's one value for the input-output table already done. X, y. Most important, the first one, 2, negative 4, that's the vertex. Another important one, find the y-intercept. What is y when x is 0? So we're going to take our formula. And we're going to plug in a 0. What is y when x is 0? I'm going to put in a 0 for my x. Zero minus 2 is negative 2. Absolute value of negative 2 is positive 2. 3 halves times 2, you can put it on the calculator, that's going to be 3 minus 4 is negative 1. My y-intercept is negative 1. And this goes right with the input-output table. And the slope, look right here. That's the slope, 3 over 2. And you can use your graph to help you with this. I might have wanted that to go over a little bit. That's okay. When x is 2, y is negative 4. There's our vertex. And I know a point. When x is 0, y is negative 1. Boom. So I know that an absolute value function either looks like a v or upside down v. And because my vertex is down here at the bottom and my y-intercept is up here, I know that it's going to be pointing up like a v. So if my vertex, if my x-coordinate of my vertex is 2, and I know 2 back, I'm at negative 1, then I know 2 forward. When x is 4, I know my y is the same, negative 1, because it's making a mirror image for that v. And I know that my slope is telling me to go up 3 over 2. So if I go up 3, 1, 2, 3, I'm going to have a point right here at x is negative 2, positive 2. And then I also know that's 2 more over. 2 more over. Following my slope up 1, 2, 3 over 1, 2. When x is 1, 2, 3, 4, 5, 6, y is 2. And that's 5 points. So all of this information that I asked you here, find the slope, the y-intercept, the vertex, make an input-output table, all of this information that you're able to find from looking at the formula is helping you to make the graph. I had a lot of students say that they're having difficulties graphing, and that's what messed you guys up on your quiz we took last week. So that's why I want you guys practicing making some graphs. If you can make some graphs, we can do more things with them graphs. And then the last thing, let's look at a quadratic function really quick. I'm asking some slightly different questions. I want to know the vertex. Is the parabola facing up or down? Make the table, sketch the graph. Okay. So again, right here, you have a quadratic function. It's in vertex form again. Number 7's in vertex form too. We got y equals negative 3. I'm going to leave the x blank. X minus 1 squared plus 2. Because I want to use that x. Okay? Since we're in vertex form again, it's very similar to the absolute value vertex form. We got vertex form of a quadratic function says y equals a times x minus h squared plus k. This used to be on your reference sheet in Algebra 1. You use it enough, you get it memorized. Where hk is the vertex. So the formula says minus h is minus 1. So our x-coordinate is actually positive 1. And our y-coordinate plus k, it says plus 2, is positive 2. We've already got the hk. We've already got a first set of values for our input-output. 1, 2. And I know from looking at the formula that my letter A right here, where this is, I got a negative 3. That's going to make my parabola be facing down like this. If it was positive, it'd be going up. So this part B is facing down. And now I want you to come up with some more values on the input-output table so you can make the graph. Sketch a graph. Where x is 1, y is 2. Right there. And we know it's going to be coming down. I can find out what's x when y is 0. If I plug in a 0 for x, 0 minus 1 is negative 1. Negative 1 squared is positive 1. Positive 1 times negative 3, negative 3. And then negative 3 plus 2 is going to be negative 1. So when x is 0, y is negative 1. That's going to go right here. And I know the mirror image is also true. Right here. So when x is 2, y is negative 1. Now I can check when x is negative 1. It's going to be the same as when x is 3. I'm going to get the same y value here. I only need to check one of them. So I'm going to take that out. And I'm going to change this to either a negative 1 or a 3. Because y, you're going to get the same thing. It don't matter which one you pick. So I'll take the negative 1 on the calculator. Negative 1 minus 1. That's going to be negative 2. Negative 2 squared is going to be positive 4. Now you take that positive 4 times negative 3. That's negative 12. On the calculator, negative 12 plus 2, that's going to be negative 10. So, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Say it's down here. 2, 3, 4, 5, 6, 7, 8, 9, 10. Say it's down here. It would be over a little bit. And this, again, this is hard for me. With this pen on my computer. Much easier on paper. But I don't have my document camera at home. There we go. Yours should be much neater than mine. We're going to have a parabola. That's that U-turn facing down this way. And I just asked for a sketch. I didn't ask for a perfect graph, but hopefully yours looks a little neater than mine. I hope that these examples help you to be able to answer your questions for your classwork today. And where do I stop?